In Chapter 5, we're going to be working on working with trigonometric identities, and the first section of Chapter 5, we want to start verifying or proving trigonometric identities. You remember that an identity is an equation that's always true for all values of the variable that are in the domain. And our job in this section is going to be to prove an identity or to verify that it's correct. And basically what you want to do is work on one side, show that one side of that equation can be simplified so that it exactly matches the other side. Now, I am very picky about how I want these done, and there are good reasons for how picky I am. It is really important that you start by copying the original problem down on your paper. Then you want to work down your page, and you're only allowed to simplify one side of the equation. Your job is to work on that one side and make it look like the other one. Now, if you've read your textbook, you may see your textbook authors are a little bit more relaxed about that than I am. Remember, I'm the one that's going to be grading your paper. Okay, so just kind of keep that in mind. So basically, you're going to take a look at the equation and start with the side you think is the most complicated. Look at it and think about, what do I think I could do, and start doing it. So we're going to look at some examples. The first example comes after a tip. A lot of times it's going to be helpful to rewrite your terms or the things in your equation in terms of sine and cosine. So here's our first example. When I look at that equation, I would choose to work on the left side of that equation. You might choose to work on the right side, but I think that the left side, since there's more stuff there, it's going to be easier for me to simplify that and hopefully make it look exactly like secant x. So I'm going to start this problem by rewriting cosecant as 1 over sine, rewriting tangent as sine over cosine, and now I'm looking at two fractions and I realize that I can reduce. The sines will cancel, leaving me with 1 over cosine of x, and 1 over cosine of x is secant of x. So I have verified that cosecant x times tangent x is actually equal to secant x. So here's another example. Well, I'd recommend that you stop the video, copy that problem on your paper. I'd recommend working on the the left side of that, just like in the other one. Start by rewriting cotangent in terms of sine and cosine, and see if you can simplify that. After you finished it, start the recording again and see how you did. If I'm working this problem, I rewrite cotangent as cosine over sine. So it might be helpful to write that cosine as cosine over 1. So now I'm looking at cosine squared x over sine of x plus sine of x. Now I need to add those two quantities together, so I'm going to make sine of x a fraction. And I'm going to get a common denominator by multiplying by sine of x over sine of x. So now I'm looking at cosine squared x plus sine squared x all divided by sine of x. Now I kind of skipped a step in there where I just changed this second term to sine squared over sine, but the whole point was to get a denominator so you could add them together. Now cosine squared plus sine squared, I remember the Pythagorean identity, that's 1. So I have 1 over sine of x, which is cosecant of x, and that is what I needed it to be. Next tip. Sometimes factoring will help you simplify. You're kind of following all the rules for algebra, but just applying them to trigonometric expressions. So if I look at the next example, on the left side of this equation, I see there is a common factor of sine of x. So if I factor out sine of x, the other factor would be 1 minus cosine squared x. Now, there's an identity that you've learned that says that sine squared x plus cosine squared x is always equal to 1. Well, if I move that cosine squared x to the other side of that equation, I'll have sine squared x is equal to 1 minus cosine squared x, and that's exactly what's there. So I can replace that 1 minus cosine squared x with sine of x. Oops, sine squared of x. Sine x times sine squared is sine cubed, which is exactly what I was supposed to get.